Hello, I welcome you all to this another interesting screencast, and the problem reads, replace the loading system by an equivalent resultant force and specify where the resultant's line of action intersects the horizontal segment of the member measured from A. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Benam. So first things first, let's find the components of this inclined force. So we'll have a component like so, and another component like so. Right. So what are these components? This is a 15 by the rise, which is 3 divided by 5. So 5 into 15 is 3. 3 by 3 is 9. 15 by the run, 4 divided by 5. This gives us a 12. Right. So let's have the arbitrary position of our resultant. So let's say we have a distance. We are looking at the horizontal segment of the beam. So let's assume the vertical component will be located somewhere there at distance D measured from A. Let's say we have a resultant at this point D, like so, pointing down, and then we call it as FRY. Okay, so we know that FRY times D is supposed to be equal to summation of moments about point A. Great. And then FR or Y, or we say summation of forces in the Y going up in our reference. This is equal to FRY is equal to FRY. This is equal to FRY, which is equal to a minus 20, a plus 9, which is equal to a minus 11, right? Yeah, it's minus 11, minus 20 plus 9, that's minus 11. Then we have summation of forces in the X going in this direction, of course, is also equal to FRX. This is equal to just a 12. Okay, and then summation of moments about point A and clockwise being our reference. This is going to be equal to minus moment due to 20 by 2, and then we have a positive moment, which is a 9 by 6, and then we have another negative moment due to a 12 by 2. This is going to be equal to, so we have minus 20 by 2 plus 9 by 6 minus 4 by 2. This is going to be equal to minus 10. Right. So using this equation, we know that our FRY, we found it as negative 11 times D equal to summation of moments about point A is just equal to negative 10. Therefore, our D is just going to be equal to that's 10 divided by 11. So this gives us a 0.91 meters. Alright, again, this is just what we assumed. Don't worry to say it's supposed to be less. We are going to redraw that. Okay, so this is 0.91 meters, and this is equal to 11 newtons, right? Kilonewtons. So let's redraw this. Before we redraw, let's find the resultant. The resultant is going to be equal to, using Pythagoras theorem, is equal to square root of 12, which is the x component, summation of forces in the x, and square root of negative 11. So once we square the two, then we'll have, let me just do so, then we are going to have a 12.28 kilonewtons. So 12 squared plus 11 squared, square root of that, why did I make a mistake? The 12 squared plus 11 squared, so it's a 16.27. Alright, 28, 16 not 12, sorry, 16.228, right? Kilonewtons, 16.28. We need to find the angle also, so tan inverse of that. So we have the y component negative 11 divided by the x component. Once we do the calculation, what do we have? Tan inverse of that, we have a negative 42.51 degrees. So negative 11 divided by 12, tan inverse of that, so negative 42.51. Negative just simply means if you have a coordinate system like this, we have x, we have y. An angle like this is always, this is our positive conversion, and an angle like this is a negative conversion. Okay, so that negative just simply means we are going clockwise. Alright, so now we have all the information. We can redraw this and then add the meat. So let's redraw. So we are going to do two of them. I'll just do one and transfer it. 2, 2, 2, maybe up to there, and then another 2, like so. This is good enough. And then let me do another one. 2, 2, 2, and then going up 2. Alright, so these are good, these are okay, so these are equal to each other. This point is A and this point is A. Great. So what do we have? So in the first case we found D. Let's identify D, because this is where everything starts, and our D is just about 1. Okay, about close to 1. It's not 1, but it's just close to 1. So we found D is 0.91 meters. 0.91 meters. Right. So let's write down the components. So we have one component there, a vertical component, and then what is x? How is x? X is positive, so I'm going to redraw it like this. I'm lifting it just a little bit, this, so that it's visible. All right, there we go. Is it clear? Because the beam ends here. The beam ends here. Okay. Okay, let me just mark where the beam ends. This is where the beam ends here. And at that point, the beam ends here. Alright. So this other component is like so. Okay. Is that fine? Should be fine. So we have the magnitude of the vertical component is 11 kilonewtons, and the x component is 12 kilonewtons. So we expect the resultant to be in this direction, right? Which we are going to indicate on the next beam. So on the next beam, we have the angle there, 42. So let's say our resultant, let's say, is somewhere something like that. I want a straight line. Okay, something like that. Not too bad. I think it's fine. And then we have the angle like this. We have the angle like this, which is this is a 42.51 degrees, right? That's our angle, and the magnitude of this we said is a 16.28 kilonewtons. I think this is really about it. We have the equivalent force there. We have the equivalent force. Oh, yes, that intersects the horizontal segment of the member measured from A. I think this is really about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.